So finally, we're going to look at questions in a sampling distribution of sample mean. Um, so these questions are important because they remind us about the central limiting theorem, which is really important theorem. And we have notes posted on this side about the central limiting theorem, which says that suppose all samples of size are taken from a population with mean and standard deviation, the collection of sample means forms a probability distribution called the sampling distribution of the sample mean. The mean of the distribution of the sample means equals the mean of the population. That information is important when we are going to work on these two questions. And also, the standard deviation of the sample means, called the standard error of the mean, equals the standard deviation of the population divided by the square root of the sample size. So we will use same Excel functions to find probability, but we have to consider the mean or the sample means, which will be equal to the mean of the population. And also, instead of just considering the standard deviation as we did in the normal distribution, in this case we are going to consider the standard the standard error of the mean, which equals to the standard deviation of the population divided by the square root of the sample size. So how do we understand questions that will need to apply this theorem? So question number 1 actually is very clear. It says the length of time in hours it takes an over 40 group of people to play one soccer match is normally distributed. This information is important, that the population is considered to be normally distributed with a mean of 2 hours. So you can see this is the average of the population, and the standard deviation of 0.5 hours. That also is the standard deviation of the population. Now, suppose a sample of size 25 is drawn randomly from this population. So that shows that we are looking at the sample means. So the question says, is the distribution of the sample means normal? Explain. So according to the central limiting theorem, if the population mean is normally distributed, then any sample that is selected from this population will also be normally distributed. That's why when you add the means or the sample means, they will be the same as the mean of the population. So for any question, if you are asked, is the distribution of the sample means normal, when the sample is drawn from the normally distributed population, so it should be actually normal. So that's the explanation you should provide. Now the second question says, what is the mean and the standard distribution of the distribution of the sample means? So in this case, the answer is simple, because we said here that the mean of the sample means, when you collect all of them, then they are equal to the mean of the population. And then what is the standard distribution of the sample means, or the standard deviation? The standard deviation, which is normally called the standard error, it is the standard deviation divided by the square root of the sample size. So if you can see here, we have the sample size of 25, and also we have standard deviation. So to find the standard error, that means we'll take 0.5 divided by the square root of 25. So what is the probability that the mean of the sample is less than 1.7? So in this case, our probability can be written as follows. Probability of x. So here we're talking about less. So is probability of x such that x is less than a value. Is less than a value. This one should be this one. So here we are talking about the probability of x such that x is less than 1.7, and so the other one here is more than 2.2, and we're asked what is the probability that the sample mean is between. So here we are talking of the in-between questions. So remember, to find the probability of x such that x is less than 1.7, so normally we have to use the Excel function to find the probability, and so we can find norm dist. We should use norm dist, where we should put the value, the average, standard deviation, and the cumulative. So in this case, the value which you should put, definitely it should be this one, and the average, because of the central limiting theorem, we'll take the average of the population, because we know that the sample means the distribution of the sample means will be equal to the mean of the population. So we'll consider this average, and standard deviation. In this case, we will consider the standard error, and so we'll take 0.5 divided by the square root of 25, and then because this is cumulative, so we're going to say true for the cumulative, and we'll find the answer. So for the case where we are talking about the sample is more than 2.5 hours, so that means we'll consider probability of x such that x is greater than 2.2, and you should remember that this is the area to the right of the value, and in this case we need to find the area to the left. And so when we consider Excel function, we should write 1 minus norms and norm dist, and everything remains the same. So that's how we can answer the second question. And what is the probability that the sample mean is between 1.8 hours and 2.3 hours? So all we have to do is we will start with this minus this one. So just put equal sign and type norm dist, so we'll do the norm dist where our value will be 2.3, and then we'll have the same average and the standard error, which is standard deviation divided by the square root of n, and cumulative, and then we will minus norm dist And so in this case, we will put this value, which is 1.8, and then we use the same average of the population, and then we'll consider standard error, and then that will be cumulative. And so we'll get in between from 1.8 and 2.3. I think the same approach can be applied to question number 2. So please try to work on it, and let's see what you're going to get.